Our children deserve better. That was the conclusion of the Chief Medical Officer, most senior doctor in the United Kingdom, in 2012. In fact, she gave a whole report in 2012 to highlighting the hundreds of thousands of children within our primary schools in the United Kingdom who have some kind of neurodevelopmental disorder, something which interferes with their development. And these disorders cause profound problems to these children. And we're currently failing these children. This is the conclusion of her report. This isn't a problem that just happens in the UK, this is a global problem. Now, I'm a neuroscientist who works in the city of Bradford. It's a great privilege to work in the city of Bradford. And I can tell you that the evidence that we see in Bradford is completely consistent with CMO's conclusions. Now, Bradford's a fantastic city, a real privilege to work in it. It's the 6th largest city in the United Kingdom. It's in an area of outstanding natural beauty, in the county of Yorkshire, in the north of England. It's a really interesting city. A city that was once incredibly prosperous, built on the wool trade. It was once the wool capital of the world. And that economic prosperity brought large-scale immigration, particularly from the Kashmiri region of Pakistan, which means that Bradford is a fantastically culturally diverse city, with all the richness that that brings with it. But like many cities throughout the world, Bradford faces challenges. Because that wool industry collapsed. And with that collapse in the wool industry came large-scale economic decline. And Bradford now faces challenges. And it's a city that has large inequalities within it. So we have some of the wealthiest areas in the United Kingdom and some of the poorest areas. And that makes Bradford a microcosm of cities throughout the world. A microcosm of the challenges facing cities throughout the world. And that means that Bradford provides us with an excellent opportunity to address questions about how we can help those children who are being failed in primary schools throughout the United Kingdom. And it was this vision that led the brilliant John Wright to set up a really exciting research project that's following 13,500 children from birth through development, in order for us to understand what are the critical factors that influence successful health outcomes and successful educational outcomes. And so the project's tracking the children over their lifespan. And in that population, we have 176 pairs of twins. This is just one of the pairs of twins. And what we can do is see how those twins change over time. So these beautiful photographs are taken by Ian Beasley, who takes pictures of their twins as they grow up year on year. And what we can do as scientists is understand the impact on development of those sort of changes. So what are we discovering? Well, I think one of the big findings that we should be excited about is the finding that perception is fundamentally important to childhood development. And my big TEDx idea is that perception is the keystone of primary education. And what I want to do now is defend that claim, use some evidence to support my claim, and then think through the implications of that suggestion. Okay, what we need to do, first of all, is define our terms. It's really important in science that we define what we mean. So when I'm talking about primary education, I'm talking about the educational processes that happen before children reach the age of 12, which is typically when children in the United Kingdom go to secondary school. And when I'm using the word keystone, I mean the fundamental element without which everything breaks down. Now, perception's more difficult to define because different people use the word in different ways. But when I use the word perception, I'm defining it as the decoding of information. And we're all familiar with the idea of information. It's said that we live in an information age. But actually, information has been important to humanity right back through the mists of time. Even when I was a lad, we used to send information to one another. There were just a lot more wires involved. So information is really important to humans. But in fact, information is central to all of life. Because evolution is the transmission of information. And about 600 million years ago, evolution came up with this brilliant trick. It invented a device that could decode and encode information. And the invention of that device created an explosion in the genetic transmission of information. So that 600 years later, we can consider the ultimate information processing system, the human brain. And the amazing thing about the human brain is it develops those information processing capabilities over childhood. So let's have a look at those processes in a little bit more depth. Now, for people who aren't familiar with the field, that's a child. And as a neuroscientist, I can tell you that children are complex. They're very complex systems. And one of the things that we try and do in science is we try and simplify complex things. We produce models that make it easier to understand the really important features. And I'm extremely fortunate to work at the University of Leeds, where we have brilliant engineers, like Dr. Ray Holt, like Dr. Peter Kummer, who can help me produce a simplified representation of this sort of complex system. So this is what we managed to produce. So if we can bring it up. Let's try again. Now, there's a technical term for this type of model in neuroscience. We call it a box. But this isn't any ordinary box. This is a box that has an input and an output. It's a box which is exquisitely able to decode and encode information. So I want us to look at that system in a little bit more sort of detail. So this captures the essential processes that occur in the brain. This captures the essential processes that occur over childhood development. Because childhood development is about decoding information, perceiving the world around us, in order that we can act around the world. And now the processes which are involved when a baby first learns to move their hands and reach and grasp objects. They're the processes which are involved when a toddler first learns to walk. The processes involved when a child starts to learn to ride a bicycle. And these processes carry on throughout life. So my colleagues in psychology, Dr. Richard Wilkie, Dr. Jack Billington, Dr. Callum Mole, spend a lot of their working time trying to understand how we use perceptual information to steer cars, to brake cars so we don't run into the back of another car. So that decoding of information to control action is absolutely central to human behaviour. And when we start thinking in these terms, we start realising some very profound things. So one of the profound things is that perception is intrinsically linked to action. They're two sides of the same coin. And that reminds us that perception is an active process. We don't passively receive information. We're information predators. We hunt out information. So in your lifetime, you will hunt out information by making eye movements more times than your heart is going to beat. And my colleagues, like Dr. Mel Burke and Dr. Rachel Coates, spend their time trying to understand the complex brain structures which are completely dedicated to helping us hunt information from the environment. And this idea that perception is active reminds us that learning is an active process. And we've realised that learning is an active process for a long period of time. So, just to be clear, Benjamin Franklin wasn't born in Bradford. Benjamin Franklin was born in Boston. And to the best of my knowledge, Ian Beasley didn't take that photograph. But what Franklin realised was that learning is an active process. And work in our own laboratories has supported this insight. So Dr. Earl Jameson in the laboratories, has used in our laboratories, has taught people to move their arms through complex force fields, the type of thing which babies have to do, how to learn to move your hand. And what Earl found is that if you used a robot to help guide someone's hand, they didn't learn. The only way they could learn was by actively moving their own arms, because learning is an active process. In fact, Earl found that providing disruptive forces that force people to explore their environment produce the best learning of all, because learning is an active process. And we're extremely good at actively hunting out information and using that information to learn. And that's a testament to 200 million years of genetic engineering, 200 million years of producing an outstanding perceptual motor system. And in fact, it's such an amazing system that we take it for granted. And it's a system that is neglected when we think about childhood development in educational terms. So that's my claim. My claim is that the perceptual motor system is fundamentally important. And yet, we're obsessed when we think about childhood development in terms of numeracy and literacy. We're obsessed with the clever cognitive stuff that the brain does. But what we've got to realise is those clever cognitive tools that we possess are underpinned by the perceptual motor system. And that's true both at an evolutionary level. The last 6.5 million years brought the brain areas that gave us literacy and numeracy. But those brain structures developed from the underlying perceptual motor apparatus of the brain. And there's lots of evidence now that not just in terms of the origin of the species, the history of our species, but in terms of the development of the individual child, those cognitive capabilities, those higher order cognitive capabilities, are built up by physical interactions with the world. So there's amazing things that we can do, representing numbers, representing space, representing sort of time, are founded upon our perceptual motor interactions with the world. Perceptual motor interactions that are often neglected in primary education. So my claim is that perception is the keystone of primary education. And I believe it's something that we're neglecting. It's a basic building block that we're neglecting in primary schools. Well, anybody can make claims about what they think is important in primary school. When I said it's difficult to, perceptual motor abilities, they may be not as easy as they're made out. So anybody can make claims about what they think is important in primary school education, but we need to move towards evidence-based practice in education. So I want to look at some of the evidence that supports my claims. So let's start with one of the most basic perceptual skills, obtaining information through our eyesight. So work done by Alison Bruce within the BIB team has gone and looked at the visual status of children in primary schools within the Bourne and Bradford cohort. And what she's found is really quite shocking. Because she found 6% of children had some kind of visual deficit, some kind of problem with seeing the visual information they're being presented with. And 4% of children had eyesight at a level that would cause them to be classified as having a visual impairment. And even after Alison had identified these children having problems and sending them to the eye hospital or local eye practitioner, even after 2 reminders, 27 of those children still hadn't had any visual correction. So what this means is that we have large numbers of children within primary schools who can't see the information that we're trying to teach them. Now, people are very concerned about the 100,000 children who are doing poorly, who are failing their literacy and numeracy tests in our national standardised assessments. But I think we should be worried about the 270,000 children who can't see very clearly, or the 180,000 who have some kind of visual impairment within the classroom. Surely that's sort of something that we should be tackling as an educational intervention. And this isn't a problem that's unique to the United Kingdom, because our wonderful colleagues across in Norway who work at the Norwegian Vision Centre in Kongsberg are finding similar patterns in children across in Norway. And it's probably a problem which is going to increase because we're actually facing a myopia epidemic. More and more people are becoming short-sighted. So this is something I believe we need to take seriously within primary education. And of course my suggestion is that this has an impact upon learning outcomes. And we can test this idea because we actually measure receptive vocabulary in these children. So that's the number of words that children know. And what we find is there's a relationship between the children's visual status and their receptive vocabulary. So children who can't see clearly know less words. The other thing that we do is we measure the children's basic perceptual motor capabilities. So we've invented a system, we call it CCAT, and this system allows us to precisely and objectively measure a child's pen skills. It allows us to measure their perceptual motor capabilities. And what we find is there are large numbers of children who have difficulty with these basic motor skills. They have difficulty applying forces to the pen in order to produce skillful movements. And estimates vary. We think there's probably a couple of 100,000 of these children within schools in England. And we know, there's been a number of studies, that the consequences of these problems are absolutely enormous. The children with these type of difficulties suffer from all kinds of health problems later on in life, such as obesity, and they suffer from all kinds of mental health problems. The incidence of suicide is much higher in later adult in children who have these type of difficulties. And these difficulties can be treated. So one of the things we're doing is working with a wonderful group of schools within Bradford called the SHINE Consortium. We're working with those schools to help empower the teachers to use interventions that can help the children improve their fine motor skills. And these are evidence-based techniques. We know these techniques work. And colleagues of mine, like Dr. Faisal Mushtaq, are actually using these techniques in other special need populations. Laparoscopic surgeons, as so happens. So we can use evidence-based techniques to improve the fine motor skills of children. And we've got to do that because the consequences of not doing it are profound. But the problem is, the authorities don't seem to care about basic handwriting because it doesn't feed into numeracy and literacy. And yet all of us know, any student in this audience knows, that you can know all of the information about your degree, but if you can't communicate that information, it counts for nothing. So there are children who are spending the whole time thinking about what the hand is doing, as opposed to learning all of the clever cognitive stuff we want them to learn. So this is a problem that we've got to tackle within primary schools. And in fact, these problems, I believe, have direct implications for literacy. So my colleagues, Dr. Amanda Waterman and Dr. Richard Allen, have done a series of studies showing that memory is enhanced by action. So for example, Amanda ran a study where she showed people visual shapes, young children visual shapes, and then they had to draw the shapes from memory. And the children's ability to do well on that task predicted their national attainment in handwriting skills. But even more interesting, it predicted their attainment in reading. Because perception and action are intrinsically linked. Writing isn't just some passive output process. Writing helps decode information. That's why we write things down when we won't remember things. Now, I've been really focusing on educational attainment. Things like writing and reading. But clearly one of the aspects that's really important in primary education is the child's social and emotional well-being. actually, those measures we took of fine motor skill predict a child's social and emotional well-being. And that makes some sort of sense, because our emotional well-being is related to our social interactions with one another. And how do we socially interact with one another? We decode information about other people, and then we act. We respond. That's the only way that we can communicate with one another, through perceptual motor interactions. So it's perhaps not surprising that the children's social and emotional well-being is tied to their perceptual motor capabilities. So all of this suggests, doesn't it, that we should be really focused on trying to make children more active, supporting their perceptual motor development. And teachers get that, and head teachers get that. But there is a problem with educational authorities, with education ministers, in that they're measured by literacy and numeracy scores. So they're obsessed with literacy and numeracy. So this belief that any time spent in physical education is time being taken away from sitting the children at their desks and throwing information at them. And I want to suggest that this is misguided. So one of my colleagues, Dr. Liam Hill, ran 2 beautiful studies where he gave children a burst of exercise in the middle of the school day. And then he measured how well the children could pay attention at the end of the school day. And what he found is that when the children had that burst of activity, they found it easier to concentrate on the tasks they were given. So in fact, keeping children active might produce much better learning outcomes. Because perception is the keystone of primary education. So, I believe that we should be working hard to enable children to be more physically active. Physical education has been eroded year after year after year within the schools. And I don't want us to start going back to those old days where physical education was interpreted as sort of running around the edge of some muddy field. But what we need is proper perceptual motor education embedded in primary schools. And I think schools is where we need to tackle these problems. Because the existing model, trying to deal with the hundreds of thousands of children within the schools who are having problems, is to try and go into those schools, identify the children with the difficulties, and send those children into the hospitals. You don't want to send children to hospitals for disease and stuff. And they can't cope. So what we're really doing is tackling the tip of the iceberg, putting some child on some huge waiting list. Eventually they see some consultant who confirms they have a problem, but says we don't really have the time to deal with that problem, and sends them back to the school. Wouldn't it be much better to enable schools to deal with those children, to help those sort of children? Because typically it's in the schools the children need help and support. So in conclusion, I think we need to take perceptual motor development seriously within primary education. I think we need to empower teachers to identify children who are having difficulties and give them the tools they need to support those children, to help them achieve their academic potential, to help them avoid the health, physical and mental difficulties that we will know will occur otherwise. But actually, all of us have a responsibility to do something about it. All of us need to encourage children to be more active and to provide environments that allow children to be active. Perhaps that means us driving a little bit less, so children can walk to and from school safely. And we need to persuade educational authorities not to be obsessed with numeracy and literacy scores, but to think holistically about a child's development. And we've got to support parents who want to try and help their children acquire fundamental skills. We've got to persuade governments to fund this type of work. All of us have a responsibility to try and help children become active and achieve their potential, because perception is the keystone of primary education, and our children deserve better. Thank you.